Hi, my name is Richard Rue, and this is my presentation for our first paper for MBA 639. I wrote my paper about kind of that neuroscience topic we had talked about. I think it was week 7 and week 8. So my paper is titled Basic Neural Circuitry and its Role in Finance. So kind of as we talked about oxytocin and some other neuroscience topics. In my undergraduate career, I focused actually on biology, and one of my focuses was in neuroscience. So one of the things that I really looked into was neural circuitry. And I revisited that topic in this paper, reading about different techniques and studies that had been done with neural circuitry and their relationship to finance. So kind of as an introduction, we all know what behavioral finance is. We've talked about it. It's that extension of traditional economics in order to explain some of the irrational behaviors that humans have. The one I use in my paper to kind of give people an example to springboard off of is that gambler's fallacy, where people kind of mix up the fact that if an outcome keeps happening, we think that it becomes less likely that that outcome will happen again. We have learned in this course that that is not true. And that's just a trick that our mind plays on us and causes us to make that decision. So, what is neural circuitry? Neural circuitry, your brain is connected in this like extensive network of neurons, and you have over 100 billion neurons within your nervous system, and each one of these neurons forms between 20 to 100 different connections. So you think about that, that's an unfathomable number of connections that our mind can make. And it's through these connections that our mind begins to make, to learn things and to form new memories. And this happens when our mind, as we learn something, a pathway gets activated through these neurons. And as we continue to learn something and do it over and over again, that pathway gets activated more and more. So that means when this pathway keeps getting activated, it causes this physiological change within the neurons that's going to cause the, if you will, strengthening of that neural connection, making it faster, more efficient, more likely to be activated if we are re-exposed to that situation that we had learned. And ultimately, the formation of memory occurs when this pathway becomes so strong that it's almost instantaneous when we see it. So if you think about it, when you see something and you're trying to remember what it is, maybe you've only been exposed to that thing 4 or 5 times. But let's say you see your dad's face or your mother's face. When you look at them instantaneously, you know, that's my mom, that's my dad. And that's because we've been exposed to this so many times over and over again that that pathway has become so strong that our recall is almost instantaneous to get back to that part of our brain where the connections between neurons have been made in order to encode that memory for ourselves. So that's kind of the basics of neural circuitry. And the reason that it's so important is because that's the way that our brain understands and retains information. So if we can kind of elucidate that further, this could go a long way to helping us understand some of the behavioral aspects that enter into finance. Why do things that should be rational decisions for us become irrational? What changes are going on in the brain that are causing these behavioral changes to occur to affect our financial decisions? So one of the papers that I did find that I found very interesting actually came from 2003. So it was an older paper, but it was really important because it was kind of the springboard that launched this whole investigation into the neuroscience behind finance. So what they did at this time, functional MRI was really cutting edge, and it was allowed researchers to look at what brain regions were being activated at different times in response to exposures to different environmental factors. And they were investigating the reward system. So inside of our brain, we have a reward system that operates, that gives us sort of a good feeling, that good feeling when you do something good. Some of the common rewards for mammals and human beings are food, sex, and money, as well as companionship. So kind of our primary ones are the food, the sex, and companionship. And we call this a secondary one, which is money, because it's not really a creation of nature, it's a creation of humankind. And what they were investigating was whether or not this secondary, if you will, reward of money acts similarly within our brain as the primary ones do. So what they did is they were exposed people to money through different games. They did some gambling games, they did some high-risk games, some investing games, to give people a sense of euphoria and to feel rewarded if they did well and receive a monetary reward. So what they looked at was when they gave people money, they tried to study what path these neural circuits took throughout the brain and followed them through the different brain regions. By seeing which brain region lit up and then quantifying how much those brain regions lit up and were activated, we can understand what neural circuits were really involved there and what brain regions were highly activated in response to money. So what they did after figuring that out was they compared that with the neural circuits and observations they had made with some of those primal reward systems. And what they found was that